Hi everyone, so in this part we're going to look at alkanes. We'll see alkanes and the physical properties of alkanes. So here's what you need to know according to the IGCSE syllabus. So properties of alkanes, unreactive in terms of burning, then describe the bonding in alkanes. So for those doing extended course, you'll need to be able to name and draw structures of unbranched alkanes, isomerism, and substitution reactions. Okay, so let's see. We're going to look at structures. So name and draw. So we're going to look at the name and the drawing of the structures. Okay. So, alkanes are hydrocarbons, which means they contain carbon and hydrogen atoms only. So, remember when we said that the names, so the start, the name where the start of the name tells you how many carbon atoms there is. So, because we're looking at alkanes, so everything will end with ane, and we'll use the prefixes to say how many carbon atoms there's going to be in there. So if it has one carbon atom, so the name will start with meth, so it's going to be methane. If it's two carbon, so the name will start with F, so then it's going to be ethane. 3 carbon, it will start with prop, so propane. It's a single word. And 4 carbons is going to be butane. Right, it should end with ane, and the prefix tells you how many carbons there is. You should know the prefixes, what they mean. Now, structural formula shows all the bonds between all the atoms. Okay, so methane has 1 carbon. So let's draw the 1 carbon. Only 1 carbon, and because alkanes are hydrocarbons, they contain carbon and hydrogen only. Remember when I told you that carbon is in group 4? So carbon is in group 4, which means it has valency 4, means it will form only 4 bonds. It needs to form 4 bonds. It cannot form less than 4 bonds or more than 4 bonds. And hydrogen form only 1 bonds. So we'll apply this here. So carbon forms 4 bonds. So 1, 2, 3, 4. So there's 1 carbon. The rest is going to be hydrogen. H, 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 and H. Structural formula. This is going to show groups of atoms and a few bonds. So in this case, it's just going to be, so how many carbons you have? 1 carbon. How many hydrogen you have? 4 hydrogen. Okay. In this case, molecular formula and structural formula will be the same. So in this case, it's going to be CH4 itself. Let's see ethane. Ethane, 2 carbons. 1 carbon, 2 carbon bonded to each other, single bonds. It's alkane, we're referring to alkanes. Alkanes, they have all single bonds. And the rest of the bonds is going to be hydrogen. Carbon needs to form 4 bonds. So 1, 2, 3 is already formed with carbon, and 4th one. So H, H, H. We'll fill this one as well. H, H, H. So this is ethane. Our carbon is forming 4 bonds. Each carbon is forming 4 bonds. So 1, 2, 3, 4. And the other carbon as well is forming 4 bonds. 1, 2, 3, 4. So you see all the number of respected there. Okay. So what will be the structural formula? So in this case, structural formula will show groups of atoms. So we'll see this one as a group. So CH3 this one as another group, CH3. Okay? And the molecular formula shows the number of atoms. So number of atoms, there's 2 carbons and there is 6 hydrogen. Let's see propane now. So propane, there's 3 carbons. So let's have our 3 carbons. 1, 2, 3, all single bonds because it's alkanes. And then we'll fill everything with hydrogen. This carbon, this one needs to form 3 more bonds. 1, 2, 3. This one is already forming 2 bonds here. Okay, so 1 bond here and 1 bond here. So we'll add 2 more. This one is forming 1 bond, so we'll add 3 more. And then we fill with H everywhere. So that's propane. Okay, so we'll show the groups of atoms. So we'll group this. So CH3, CH2, CH3. Okay, that's how we'll show the structural formula. And then the molecular formula, which shows the number of atoms. So how many carbon we have? 3 carbons. How many hydrogen? 8 hydrogen. So that's the formula of propane. Whenever you are asked to draw propane, propane always looks like this. Okay, it's fixed. Butane, so how many carbon will it have now? Butane, 4. 1, 2, 3, 4, all single bonds. And each carbon should form 4 bonds. So let's fill in with hydrogen. We fill with hydrogen like this. Okay. So each carbon is forming 4 bonds. Always check once you have drawn the formula, you have drawn the structure, always check that it's forming the appropriate number of bonds. And for the structural formula, so 1 group, 2 group, 3 group, 4 group. So let's draw one by one. So CH3, CH2, but how many CH2 do we have? We have 1 CH2 here and a second CH2 here. So we'll put CH2 twice and then CH3. Okay, it's fine. You could also write it like this. CH3, CH2, CH2, CH3. That's fine too. It's the same thing. And then the molecular formula, how many carbons we have? 4 carbons. And if you count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogen. H, 10. Okay. So C4H10. So these are the members of the alkane homologous series. So these are successive members, and if you look at the members, remember the properties of the homologous series. So if you look at the members, so this is CH4, CH4, CH3, 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 then CH3, CH3, CH2. We're adding a CH2 here. So we add a CH2. We have added a CH2. We have added a CH2. If you look at this one here, we have added a CH2 to the previous one, to propane. So if you add a CH2 to propane, you end up with butane. So you see that for each member, you're adding a CH2. In this case, it's a bit less obvious, but if you kind of do a maths, so CH4, let's say it's possible to add these. So CH2, you end up with C2H6. Okay, kind of something like this. So that's the second member. So that's the first member. That's the second member of the alkane. Let's add. So C3H8. You see, that's the third member. You add CH2, C4H10. You see, that's the fourth member. So remember, we were saying that you add CH2 to successive members. So that's what it is. Okay. So what we can notice about alkanes. So first thing, for each member, for each successive member, you add a CH2. Okay, that's first thing you notice. So yeah, so that's the first one. And the second thing we notice is that they can be represented by a general formula. Let's see what that means. So we have CH4. So here number of carbon is 1. So CnH2n plus 2. That's the general formula for alkane. So in this case, N is equal to 1. Therefore, you end up with CH21 plus 2. Do the math. So 2 times 1, 2 plus 2, 4. So that's the first member. Second member would be C2H, 2 times 2 plus 2. So that's C2H6, second member. Third member, using this general formula, you can find any member. So C3H2 times 3 plus 2. So that gives you C3H8. Let's say you want to find the 10th member. C10H2 times 10 plus 2. C10H22. So no need to go and draw 10 carbons to find how many hydrogen will fit in. The general formula will tell you how many hydrogen will fit in the formula. Okay, so you see, the general formula can be used to predict the formula of any member of the homologous series. So let's see this. So they can be represented by the general formula. You have to know this. Very important. So for alkanes, that's for alkanes. Now, we've already covered this, but let's go through it again. Carbon is in group 4, always form 4 bonds. Hydrogen, valency 1, can form only 1 bond. And make sure that you check your structure once you've drawn them so that you don't get more than 4 bonds or less than 4 bonds for each carbon, and that there is 1 bond for each hydrogen. Now, this question asks you to find what's wrong with this formula. So write down what's the correct formula should have been. So let's draw that. CH3, CH, CH3. So I'm drawing it. I'm just following the structure. So if you look at this carbon here, carbon is forming 1, 2, 3, 4. Good. Carbon here is forming 1, 2, 3. So that's wrong. It's forming just 3 bonds. This carbon is forming 1, 2, 3, 4. Forming 4 bonds. So this is good. So which means that this carbon should form 4 bonds. So which means that the structure should have been CH3, CH2, CH3. Okay, so that was missing. Right, let's see the next one. You have this structure, looks a bit more complicated. So CH3, we'll draw a CH3. I'm just going to use the formula and draw it. CH2. Okay, CH3, actually the CH3 is down. Wait. Yep. So there's H, there is CH3, and then there is H, CH2, and then CH3. Immediately you can spot what's wrong. You see this carbon is forming 5 bonds. Okay, so either this one goes or this one goes away. So one of these should move away. So that should be, let's remove the H. Okay, so it should have been this instead. Okay, so means that this carbon is forming 5 bonds, so it should form only 4 bonds. So either you remove this or you remove this to get the correct structure. I've chosen to remove this one. Sorry. Yeah, this one goes. Okay, so these are the correct structures. This and this. Now, isomers. Isomers, let's see what are isomers. So these two, they are isomers of each other. Let's write the molecular formula. Molecular formula, you just need to count how many there are. So carbon. So 1, 2, 3, 4, 5, 6 carbon. So C6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 hydrogen. Let's count this one now. 1, 2, 3, 4, 5, 6. 6 carbon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 hydrogen. So 14 hydrogen, they have the same molecular formula. So what's an isomer? So these two, they are isomers. They have the same molecular formula, but they have the different arrangement in space. If you look at this molecule and this molecule, the atoms are arranged differently in space. In this one, you see that CH3 is bonded on top, and in this one, there is no CH3 bonded on top. We call this branched. This is branched. This is a branch. So here it's a branched molecule, here it's not a branched molecule. This is a linear molecule. Linear. Okay, so what are isomers? So isomers have the same molecular formula but different arrangement of atoms in space. Okay? So first example, you have to draw the isomers of these alkanes. So C4H10. So let's draw the isomers. So we're going to use the tip, count the number of carbon atom in the longest chain. So we're going to vary the number of carbons in the longest chain. 4 carbons, so let's start with 4 carbons. 1, 2, 3, 4. We'll fill in the hydrogen later. Okay. Then let's try 3. 1, 2, 3. So because there's 4 carbon, I need to include 1. So I'm including 1 at the bottom. Okay, and then let's try for 2 carbons. But if I draw something like this is the same as this one. They are the same because you see the carbons are linked in the same way. First carbon is linked to second carbon is linked to third carbon, which is linked to the fourth carbon. So which is the same. First to second, second to third, third to fourth. So it's the same. So this is not an isomer. So we have 4 carbon, 3 carbon. And that's it. Anything else will be the same as these two. If you can figure out something that's different, just let me know. Okay, so then you fill in with H's. Okay, this should go away. Right? So you see they have the same molecular formula. They all have 4 carbons and 10 hydrogen, but they have different arrangement in space. So that's one and that's the second, and they are both alkanes. So you're going to try for this one. You're going to draw that in your copybook, and then you're going to take a picture of it and upload it in the assignment. Okay? So try to draw as many isotopes as you can for C5H12. Make sure that the structures are not equivalent to each other's. Okay. So isomers have the same chemical properties, meaning that they will undergo the same type of reactions, but they have different physical properties like boiling points. So physical properties, these are the physical properties of alkanes: insoluble in water, less dense than water, so it's going to float, and they are flammable. That's why we use methane as a fuel, because it's flammable. And the physical properties change gradually as the molecular size increase. So melting point and boiling point, viscosity and flammability. Okay, so the next video we're going to see all these physical properties and how they change as the molecular size increase.